So, good evening, everyone. So, today we will discuss the tutorial or question related to the week 10 content, in which we will discuss development of the relay matrix, damping matrix, and then we will solve some free vibration on the force vibration questions for the response for the multi degree of freedom system. So, Mahesh, do you have any doubt? Like I have seen your doubt on the portal. So, whatever we have discussed during the last class, that was correct.
Yes, no, I don't have any doubts. But in assignment 8, I didn't get marks for a first question. We have already discussed, right, regarding this
That will
equation.
that is updated. Like, did you receive any?
I, I didn't get update because I think I have chosen two options. In that, only one option is correct. I think you may have to talk to
So, did you
for
get point 0.5 marks or the 1 marks?
yes. Point 0.5 marks means I will get minimum 6 marks.
So, what was the other option? Did you choose?
Other option is the fourth option. I have chosen. That will be wrong. But the first option is right. If it is right, I will get a point 0.5 marks means 6 marks will be added to my score.
Yes, but I have to look into that. Like, what they have done. Either they have done for choosing 1 point, like the choosing only A, they are giving full mark, or if they are dividing half. I have to check with them.
Because those options are not only one chosen option bits. We have a right to choose more than one.
Yes.
That's why I'm asking. Otherwise, it's okay.
So, we will check whether it will be happen or not.
Okay, sir.
Okay. So, let us start. Let me share my screen so that. This screen is visible. If yes, then let us start.
Yes, sir. Yes, visible.
So we have given a question like the property of the three-story shear building are given in the figure. If the mass is the 4500 kg, K is the 300 kilonewton per centimeter. We need to derive a relay damping matrix such that the damping ratio is 5% for the first and second mode. So we need to compute the redamping matrix and then the damping ratio for the third mode. So we need to do the question the two parts. So first part is to find out the what are our natural frequencies and what would be our mode shapes. I think mode shape will not be useful in that. Only the what are the model frequencies are that will be useful. So let us go one by one. So now I am not going to that how do we develop the stiffness matrix and the mass matrix, because that is covered last two lectures. So I will directly develop the stiffness and the mass matrix. So the mass matrix is 1 0 0 0 0 0.5 m, and the K matrix is that. So here we are defining it as a K by 9. If you do K by let us suppose K by 9 as a K dash. So how much it would be? It would be 3K dash, it would be 7K dash, and it would be 9K dash. You can solve anyway, whatever you want. Okay, and those are the that is the degree of freedom 1, for this is 2, and this is 3. Okay, so my stiffness matrix would be the K1 plus K2 minus K2 0 minus K2 K2 plus K3 minus K3 0 minus k3 k3. If you put into the, like, k1 is what, 9k dash, k2 is what, 7k dash. Like, let me write it. So k1 is the 9k dash, k2 is the 7k dash, and k3 is the 3k dash. So if I will put it into this equation, I will get my k as a 16 minus 7 0 minus 7 10 minus 3 0 minus 3 3 k dash. Okay, so now you can find out the eigenvalue and eigenvector. Okay, so for this we need to do the characteristic equation. So that simply can we find out it like 16 minus lambda minus 7 0 minus 7 10 minus lambda minus 3 0 minus 3 3 minus lambda by 2 is equal to 0. So if you find out the determinant of this equation, this matrix, my equation is coming out to be lambda cube over 2 plus 16 lambda square minus 124.5 lambda plus 189 is equal to 0. So this is my characteristic equation. So can you give me the lambda 1, lambda 2, lambda 3? Can you solve this? So this lambda 1 would be the some function of k dash by m. Okay. Lambda 2 would be some value k dash by m, and lambda 3 would be some value k dash by m. So can you give me the value of lambda 1, lambda 2, lambda 3?
At this part, I have a doubt. Actually, in the previous assignment, we have to find the frequency of one slab. One slab with three frames is given, right, in the last problem.
Yes.
Uh, Suppose if we get a three frequencies,
Yes.
that means three roots, which could be the first frequency? Uh,
Whichever is the lesser is the first frequency.
okay, then uh, in the solving that's assignment, I have got the uh, uh, I have got the less frequency for a single degree of freedom system equation, that is x direction equation. In the remaining uy and u theta directions, the remaining, but anyway, answers my answers are correct. But
But actually, what happens in that case, your x is uncoupled from y and theta are the coupled. I think that was the question.
yes,
So
yes, yes.
two degree of freedom are the coupled, and the x is the different. So keep it the x is a different, and that x you can keep it either one or x, either you can keep it three. Like keep it a separate.
But okay, but in case of we are getting three frequencies, in that x direction will be the least frequency actually.
Least frequency in the x direction. Why? Like I'm not in general. It is not mandatory. Like always, it will be the x direction as the least frequency. No. But in
Uh,
that question, maybe there. I don't remember what was the answer and what was the there.
okay, okay, okay.
So that in that question, actually, I remember like x is the uncoupled in
Yes,
different degree of freedom, and y
yes.
and theta are the coupled. So those
Okay.
two treated as a different, and one is treated separately. Like that, you can do.
If I get suppose ux is in a x direction, suppose if I get least frequency, y direction, and the second one is y, third one is theta,
Yes.
which could be the first frequency in first mode.
The lesser the frequency, which would be the pure first mode.
Okay, okay. Thank you.
Like the, if you have the, like, if not the frequency, you can look into the time period. like whichever the higher time period would give you the first mode will be the first mode, then the second, then the third, from the time period wise, and the frequency would be the reverse. For the lesser, it would be the first mode.
In our case, x direction will be getting is getting less,
Okay.
and the remaining are getting second and third position.
Yes. Yes.
But in the last question, you have asked regarding mode shapes.
Okay.
Mode shapes for first and second mode. You have asked.
But that is only for the discussion purpose. I don't think you need to draw that.
Oh.
In that question, I think you need not to submit the answer for the mode shape. Is it?
Ah, yes, sir. Yes, because in the first mode we are having only an uncoupled equation, right?
Yes.
In the first frequency, uncoupled equation we are getting, but we can't say that is a first frequency.
So are you talking about the current week 10 assignment? Like,
Not current week, in the previous week assignment problem.
okay. So
I will be having doubt discussion forum. In that you can because
okay, I will do that.
okay, okay, sir.
So find out the lambda 1, lambda 2, lambda 3 for this equation.
The first one is 21.
Yes.
Second one is 9. Third one is 2.
So your first one would be the 2, then 9, then 21.
Oh, okay,
Okay.
okay.
So now using that we can find out the omega. As the k dash is, we have the uh, k dash was the k by 9. So k is what? K was the 300 kilonewton per centimeter. So k can be 300 into 10 raised to power 3 into 10 raised to power minus 2 by 9. So that would be 3000 by 9. And you have the 45,000 kg. So if you put this, we will get the omega 1 as a 12.17 radian per second. Omega 2 would be 25.81 radian per second, and omega 3 would be 39.44 radian per second. So now for the part 1, the relay damping matrix can be given as a C is equal to alpha time mass matrix plus beta time stiffness matrix. So alpha is what? Alpha is your mass proportional coefficient. Coefficient, and beta is your stiffness coefficient. ठीक है. Okay. So for these coefficient can be calculated and discussed during the class. Xi n for the coefficient for the nth mode, that would be alpha by 2 omega n plus beta by 2 omega n. So You can calculate this coefficient as the model damping is given 5% for all the cases. First and the second mode, the 5% damping is given. So the xi1 is given you at 0.05 and xi2 is given to you 0.05. So you can calculate alpha and alpha 2. So for the first mode, what is my omega? That is the 12.17 plus beta by 2 into this is the 12.17 for the first mode. For the second mode, that is again 0.05 alpha over 2 into what is that 25.81. Okay, so now you need to solve this equation 1 and 2. So please solve this and get me the alpha and beta. Can you solve these equations, these two simultaneous equations?
Alpha is 0.827.
Okay,
Beta is actually it is okay.
is it same whatever we are getting?
Yes, sir. Yes, sir.
So now you have the alpha and beta. So now you can calculate the relay matrix, damping matrix. So that would be the alpha time m plus beta time k. Okay, so alpha is your 0.827 and the mass matrix is that 45 and 0 0 plus 0.002632 into 16 minus 7 0 minus 7 10 minus 3 0 minus 3 3 into k dash by 9 k dash. So k dash is what? That uh, is the 300 Newton per centimeter is given. So that would be the 10 raised to power 3 and minus that 6 9 divided by 9. Wait, is there something is wrong? 300 3 into 10 raised to power 5. So 3 into 10 raised to power 3. Okay. So now solve this. Find out this. So whatever you will find out, that will be our damping matrix. So do that calculation. Let me do that. So I am getting this.
3722 minus 6.141 0.
Okay, is it okay? So that unit is Newton second per meter. Okay, keep in mind the units. So now in the part B, so part B is that you need to find out the damping ratio for the third mode. You need to find out the damping ratio for the third mode. So that you can calculate easily, like that equation we know, alpha by 2 omega n plus beta by 2 omega n. So you know alpha 0.827, beta 0.02632, omega 3 is what? That is 39.44. So can you give me the damping ratio? Xi n or Xi 3, 0.827, 2 over 39.44 plus 0.02632 by 2 into 39.44. So how much you are getting?
0.06238.
That is coming 0.06238. So we can write it as a 6.23%. Okay. So is there any doubt in this question? Anyone? If not, let us move to our next question. Now we have like number of questions with using the same example, like the three questions will follow up with the same mass matrix and the stiffness matrix, so that we do not need to do again calculation, so that we can focus only on the what the response, how to calculate the response and all. Okay. So the figure shows a shear frame, rigid beam and its floor masses and the storage stiffness. This structure is subjected to the harmonic force P naught sin omega t at the top of the floor. So that is starting with the P naught sin omega t. We're going to derive the equation for the steady state displacement of the structure. by model analysis. Okay, so for this, first we need to calculate the model frequencies, mode shape. Then we need to, what we need to do, we need to derive the equation for the multi-degree of freedom system, and then after we can derive the equation simply. So first, find out those like the eigenvalue and eigenvector, so that I will do this quickly. So the m is, so that is the degree of freedom 1, and this is for 2. Okay, so m is m 0 0 m by 2, k is 2k minus k minus k k. So now we need to do eigenvalue and eigenvector. Okay, so that would be the k minus lambda m simply. So that will come out to be 2 minus lambda minus 1 minus 1 1 minus lambda by 2 is equal to 0. So the equation, if I will write it for this, that becomes lambda square minus 4 lambda plus 2. So this is the characteristic equation. So if I solve this, I will get the lambda 1 is equal to 2 minus square root 2, and lambda 2 is the 2 plus root 2. Okay, so if you do that, omega 1 would be square root of lambda 1. So if you do that, square root of 2 minus n root 2, so that will coming out to 0.765 k by m. Okay, and omega 2 would be 1.848 k by m. So using that, we can find out the eigenvector or mode shape. So for lambda 1 is equal to 2 minus lambda 2. If I put that, 2 minus 2 under 2 lambda minus 1 minus 1 1 minus 1 by 2 511 521. So in this, if you normalize with the 521, you will get the first mode as a 511 521 is equal to 1 and 0.707. Okay, similarly for lambda 2, which is a 2 plus under root 2. Okay, so for this, if you do that, 512 522 0 0, so I'm getting 5 2 second mod, that is the 512 522 is coming out to be minus 0.707 and 1. Okay, now the like the displacement vector for the, as we have discussed in the free vibration, so displacement vector ut for the each mode, that can be given as a summation of phi n and the q1, and q1 is the modal expansion, like the response from the model analysis, like all these things. So for the each mode you have the two modes, so that will be phi n q1, phi 2 q2, and that is for the particular mode. The response corresponding to the first mode, response corresponding to the second mode. Okay. So the equation of motion for the multi-degree of freedom in generalized coordinate, what we have written as discussed in the class: capital Mn time Qn double dot t plus capital Kn Qn t is equal to Pnt. Okay. So can you give me the Mn? Mn is what? Phi and t mass matrix into phi n. Similarly, Kn is the phi and t K matrix phi n. So can you give me the M1, M2, K1, K2? So here the phi 1 is the 0.707. 1 mass matrix is what? That is M00 M by 2, and that is 0.707. 1. Find out it this how much you are getting. Similarly, this one minus 0.707. 1 M0 M by 2 minus 0.707. 1 is this. Then find out K1 0.707. 1 2K minus K minus K K, and then again this one. So anyone with the M1 M2 K1 K2, find out. Once you will be find out that, then you have the two equations for the first mode, first degree of freedom M1, then M2. Anyone with the M1 M2 K1 K2?
M1 is 1, that is M.
M1 is your M, M2 is also your M, and K1 is the 0.586 K, and K2 is your 3.41 K. Okay. Now we need to also calculate the Pn. So Pnt is what? Phi n t time P vector. So what is your force vector P here? Your P is 0 P naught sin omega t. Is it okay? So now your phi n for the calculator for the P1. So P1t will be coming out to be phi 1 is the 0.7071 times 0 P naught sin omega t. So that would be coming out to be P naught sin omega t. Okay. Then again P2t minus 0.7071 0 P naught sin omega t. So that is again P naught sin omega t. Okay. So now we have to do for the first mode response in the first mode. So that equation would be the m1 q double dot 1t plus k1 q1t is equal to p1t. Okay. So I know m1, I know k1. So that would be the p1t is what? P naught sin omega t. Okay. So if you know, like for a equation we have done in our I think third or fourth live session, mu double dot ku is equal to p naught sin omega t. Then because here we have to focus on the steady state response, so the response was that for the ut, what was that? P naught by k into
into response reduction factor.
1 minus omega by omega n square.
Sin, sin omega.
So that is called your response rd. Okay. So and multiply with the sin omega t. Okay. So here our q1 t would become as a p naught k1 1 over 1 minus omega by omega n. So omega n is the 1 square sine omega t. Okay. So we can write that as a c so that it would be easier. So here I am writing it is in the terms c1, which we call 1 minus over response reduction factor, we are calling it as a c1. So our q1t, so I know p naught how much, I don't know. K1, K1 I know. So what is the K1? 0.586K. So that is the P naught by 0.586K into C1 into sine omega t. Okay, that is the first Q1t. Okay, same for the second mode. So for the second mode, what would be my equation? M2 Q2 double dot T K2 Q2T P2T, which is P naught sine omega t. So in this also Q2T would be P naught by K2 1 over 1 minus omega 2 square time sine omega t. So again I am writing this term as a
There
C2
we have to put minus sign, right? At the qt of t.
for
Qt
what?
of t equal to minus p naught by k, right?
Minus P naught by K.
Yes, yes.
Why?
Because okay. We are getting both are positive. Okay, sir. The coefficient we have to write, right? The P1T, P2T.
Yes.
Okay, okay. Yes, sir. Okay.
So you can write Q2T as a P naught, and K2 is what? That we got K2 as a 3.41K C2 time sine omega t. So that is my Q2 response in the second mode. Okay. So now the model response. So model response can be get for the first story, not for the first. Let me write for the first mode, that would be the phi 1 q1, u2 would be the phi 2 q2. So the u1 would be the phi 1 is what? 0.707 time 1 into q1 is what? P naught by 0.586 k into c1 sine omega t. Okay. And similarly over u2 would be minus 0.7071 into p naught by 3.41 k into c2 sine omega t. Okay. So your u1 is what? U11, U21, like the for the first degree of freedom, first story, second story in the first mode. So that that can be that is the P naught by K is the same. That if I will further simplify this, so I will get 1.206 and 1.706 C1 sine omega t. Similarly, U2 is what? U12, U22, that is P naught by K minus 0.207, 0.293 C2 sine omega t. Okay. So now you can combine the response for the first story and second story. Combine the response for the first story. So that would be over u11 plus u12. So that how much it would be? If you will add, that would be p naught by k into 1.206 c1 minus 2.207 c2 sine omega t. So u2 second story, that would be u21, u22, it's coming out to p naught by k 1.706 c1 and plus 0.293 c2 sine omega t. So this is your response. If you have available p naught k, then you can be find, and m you can find out the response. So is it okay? Any doubt in this question? Anyone? Okay. Now in the next question, we need to find out, like in this we have find out the displacement response. Now we need to find out the stories here, like whatever we have done, like these using these, we need to find out the stories here force in the next question. So the next question is that, like the same question, harmonic forces applied to the top floor. So we need to drive the stories here considering the steady state displacement only by 2. Like we need to find out this either directly from the displacement, and the another method is the equivalent static method. So we need to use both the method, and when if we compare, like we are getting the same or not. So these two methods, I think, that has been covered during the week 10 content, if you go through that. So first, like for this finding out the so you can give a try for the from the displacement method, and the for the equivalent static method you can give a try, like all the things. Let me write it here. So what are the properties do we have? So properties from the last question we are getting, the first mode function mode shape is the 0.7071, and phi 2 is this, and the response for the first mode, for the first mode shape, that was the p naught by k 1.206, 1.706 times c1 sin omega t, and u2 for the second mode, that was 0.207, 0.293 c2 sin omega t. Okay, so you have the model response, like the displacement for the all the degree of freedom. So you need to follow the, so part A from the displacement. Okay, so displacement, how do you can calculate the shear from the displacement? So displacement shear story at the jth story in the nth mode, that can be stiffness time the deflection relative to that, ujn minus uj minus 1 into nth mode. So from this you can calculate the story shear for the first and second mode. Similarly, you can find out the for the another by equivalent. We will discuss later. First, you can find out. So for the first mode, what would be this? Vj equal to k into uj. J is the story number. Okay, uj minus 1. So for the first story, you can find out in the first mode. So for the corresponding to the first mode, v11 first story, that would be k u11 minus u01. So that would be 0 because the ground. v21 would be the k into u21 minus u11. Okay, for the first mode. Then for the second mode, v12, you can find out k u12 minus u02. So that would be again 0, and v22 into k into u22 minus u12. So that is for the second mode. So can you give me the v11 v22?
Here, stiffness means
K.
uh, in case of V11,
Yes,
K into U11 minus U01. Here, K means stiffness of the
first story.
first story.
Yes,
In V2 one also stiffness of first story, right?
In V21 it is the second story.
Okay. In in V12,
So that is also for the first story, and V22 for the second story.
here stiffness means what we have seen in the figure, K and K, right?
Yes, that would be the K1 and K2. The, what is the K? Not from the stiffness matrix.
Oh yes, yes, that is my doubt actually. Okay, it is not related to stiffness matrix.
Yes, it is not. Okay. So anyone with the answer, or let us discuss. So our V11 would be the K time. What is your U11? So that is the zero. So U11 is what? 1.2 P
Hmm.
naught by K into 1.206 into C1 sine omega t. Okay, so that K will be cancelled out. So that becomes as a 1.206 P naught C1 sine omega t. Similarly, V21, that would K into what is your U21, that is P naught by K into 1.706 C1 sine omega t minus P naught by K into 1.206 into C1 sine omega t. So if you do that, k will be cancelled out. So that will remain zero point 0.5 p naught C1 sine omega t. Okay. Similarly, V12, that is k. So U12 is the p naught by k minus 0.207 C2 sine omega t. So that would be minus 0.207 p naught C2 sine omega t. Similarly, V22 is k minus p naught by k into 0.293 C2 sine omega t minus minus it would become plus. So that would be the p naught by k into 0.207 C2 sine omega t. So that would also become zero point 0.5 p naught C2 sine omega t. So we have the shear from the each story. So the total shear. So in the first mode, that would be the uh, V11 plus V12, or you can do it for the for the first story. Yes, for the first story in the this is for the model number second one. So the total shear in the first story V1, that would be the V11 plus V12. So that would be your 1.206 P naught C1 sine omega t plus V12 is what, minus 2.07 P naught C2 sine omega t. So that becomes 1.206 C1 minus 0.207 C2 P naught sine omega t. Now shear in the second story, that would be the V21 plus V22. So that would be zero point 0.5 P naught C1 sine omega t plus zero point 0.5 P naught C2 sine omega t. So that will be coming out to zero point 0.5 C1 plus C2 P naught sine omega t. So this is from the displacement approach. Okay. Now we need to find out from the equivalent static method. Part B, static method. So for this, what is your shear? So in the equivalent static method, like let us suppose my F is what, mx double dot. Okay. So mx double dot, how can I write it? Omega square into x. Like normally, I am not representing it to the term. Like static force, how can I find? And x or the u, because here we are talking about the u, so that would be omega square. U is what? Phi time q1, phi and q1. Okay, m omega square. And so for the story here in the jth story in the nth mode, that would be the omega n square mj phi jn time q and t. Okay, so you can find out the shear using this and then compare whether we are getting the same or not. So for the first mode, that would be the fj1 omega 1 square mj phi j1 q1t. Okay, so in this, for the first story, f11, so omega square is what? 2 minus under root 2 k by m. Okay, mass for the first story, what will be the mj? M1, that would be m.
Yes.
And what will be the 511? That is 0.707. Okay, and the q1t is was what? That was p naught by 0.587 k into c1 sine omega t. Okay, so if you solve this, you will get 0.707 p naught c1 sine omega t. Similarly, f21, that would be the omega 1 square mj is 2 m2 phi 21 q1t. So that would be again 2 minus n root 2 k by m. And what is the mass? That would be m by 2. Okay, and the q1t is the same, and that phi 21 is the 1. So and the q1t is the p naught 0.587 k c1 sin omega t. So if you solve this, you will get zero point 0.5 p naught c1 sin omega t. For the second mode, if you do that, your fj2 would be the omega 2 square mj yj2 q2t. So that f12 in the first story, that will be 2 plus and root 2 k by m into mass into minus 0.707 into p naught by 3.41 k c2 sin omega t. So that would be coming out to minus 0.707 p naught c2 sin omega t. Similarly, f22 is 2 plus and root 2 k by m by 2, that would be plus 1 p naught by 3.41 k c2 sin omega t. So that will be coming out to be zero point 0.5 p naught c2 sin omega t. So that is the same. These are the shear forces are same. Whatever we were getting in the through the first, that these are the same. Like, no, now we these are the static forces. Now we need to find out the shear.
We have to add.
Yes, yes. So in the first story, like your shear in the first mode, that would be the f11 f21. So your v21 would be the f21, and v1 would be the f21 plus f11. Okay, so your v21 would coming out to be same. F21 is what? zero point 0.5 p naught c1 sin omega t, and v11 is what? F21 plus f11. So that would be the zero point 0.5 plus 0.702, so that will become same 1.207 1.207 p naught c1 sin omega t. So that is for first mode. For the second, similarly, that is f22 f12. So your v22 would be the f22, that is zero point 0.5 p naught c2 sin omega t, and your v12 is the F22 plus F12. So if you add this zero point 0.5 and zero point 0.5, so that would become as a similar zero point 0.5 and zero point 0.7. So that is coming out to be minus 0.207 P naught C2 sine omega t. So that is coming same. Now after that you can combine, find out the combined shear. The combined shear will also combined shear will be same as part A. So is there any doubt in this? Is it okay?
I think these are not two methods, and the first method only. I think these are incorporated. All these things are.
How these are incorporated?
No, no, no. I'm just telling like suppose in the part A, VJN is K into the story drift,
Yes,
right?
that is we are finding out the through the story drift in that we are finding out through the inertial force.
Yes, yes,
So that in some time what happens, like you do not know the like the mass or omega. In this you do not need that thing like k and stiffness. Like sometime we don't have that much property. Like if you have given like displacement and a stiffness, okay, then you can directly find out the shear.
yes, yes.
But if sometime you have given the
Omega.
mass omega, then somehow like it will be connected. Like if mass is not given to you, then you have to use this one.
Yes, yes.
So that is some, there is one question also I think in the assignment related to that. That was previous one or someone where the like the one factor only, that only through the one factor you can determine the, through the
Okay,
one method you can find out the like the shear force. So that
okay.
was the one case. So that's why I discussed both the cases. So in the next question, the undamped system is subject to a impulsive load at a second floor, which is the PT, P naught delta T, okay, where P naught is the 89 kilonewton. So we need to derive the equation for the lateral floor as a displacement as a function. So in this case, we have now we not have the P naught, like not the sinusoidal function. We have the apply a unit impulse P naught delta T. Okay. So in this your PT vector is what? 0, P naught delta T 0. Okay. Mass matrix, stiffness matrix, like we need to do the same procedure to find out the displacement as a function. Only thing that the at the end our response would be changed. Like initially the response was for the P naught sin omega t. Now this would be for the unit step function, unit impulse. So let us do that. So please write the mass matrix, stiffness matrix, eigenvalues. Can you find out? So my mass matrix would be 100, 010, 0.5, and the mass stiffness matrix would be 2 minus 1 0 minus 1 2 minus 1 0 minus 1 1. into k. So k minus lambda m, if you do that, so I'm writing the final eigenvalue and vector. So the lambda 1 is coming out to be 2 minus under root 3 k by m. Lambda 2 would be 2k by m. Lambda 3 would be 2 plus under root 3 k by m. So if you solve this, your omega 1 is 18.42 radian per second. Omega 2 is 50.33 radian per second. Omega 3 is 68.75 radian per second. Okay, and based on that, your mode shapes were phi 1 is the zero point 0.5, 0.861, phi 2 is minus 101, phi 3 is zero point 0.5. Okay, so now to solve this, we need to find out the, like our generalized equation would be what, mn qn double dot t plus kn qn t is equal to pn t. So can you give me the m1 phi 1 t mass time phi 1, m1 m2 and m3, similarly k1 k2 k3. Please give me those things because you have the phi, you have the mass matrix, so you can do that. Please give a try to give me the this value, and then along with that we will find out that pnt, which is phi nt times the pt. Okay, so p1t, p2t and p3t. Please do the calculations. Anyone with the M1, M2, M3, K1, K2, K3?
M1 is 67490.
67490.
Hmm.
67500. It should be.
M2 is 67500.
I think M1, M2, M3 all are same,
Okay.
because M1 is coming out to be 1.5 m, M2 is 1.5, M3 is also 1.5.
Oh, okay, okay. I am taking as a 1.499 like that.
1 point.
499.
Okay, you are okay, 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 okay. You
That's
are taking 2 3 decimal places, so round of these things, so that doesn't affect our answer much. And the K11 is coming out to be 0.402k, and K2 is 3k, and that is K3 is 5.6k. So if I do that, 1.5 time m is the 45,000, so that is coming out to be 67500 kg, 67500 kg, 7500 kg. You do that, stiffness is the 57,000 kilonewton meter, so that is 22914 kilonewton meter. And this one is the 1700171 kilonewton meter, and that would be the 31920 kilonewton meter. Okay, 5.6 into. And can you give me the P1, P2, P3? So the and the P naught is given to you or not? P naught is the 89. Okay, so that would be your 89 delta T. So how much? That would be 0.866 P naught delta T. So if you do this, that will coming out to be 77 delta T kilonewton. Second one is 0, and third one is coming out to be again negative 0.866 P naught delta T. So that would be negative 77 delta T kilonewton. P1, P2, P3 are known. Now the solution, like the equation we have, that what is our equation? M and Q1 double dot T plus Kn Qn T is equal to Pn T. So the solution for the impulsive loading is what? Do you know what is the solution for the impulsive loading? If I have the equation mu double dot Ku is equal
Uh,
to delta T.
then P1 of T, how we are calculating 0.866. Then
P1T is like phi n. What is your phi n? This
phi
is
2,
phi
phi 2,
phi 2 is what is -101,
yes, yes. Then,
and then
uh,
PT is what? 0 P delta T, P naught delta T is 0.
okay,
So
okay,
like if my 101 and that was 0 P naught delta T 0, what will I get?
okay, 0.
Yes, so that's what we have done. Okay.
Then you are mentioning 0.866. That's why.
No,
No,
for the P1 and P2 was there, huh? not the
Uh,
P2. P1 and P3 was there.
okay, okay, okay. Sorry, sorry.
Look at into the mode shapes.
Okay, okay, sorry.
So what is the response for this unit impulse function? If you remember, do you remember that response was ut I by m omega n sine omega t, and where this is the unit, so that would be the one. So the response is 1 by m omega n sine omega n t. Okay. So for the first mode, your q1t would be, so that was your 1 by m omega n sine omega t was for the unit. Then we have the multiply with the p naught, because that pulse is the p naught time delta t, so that will be the p naught also is there. Okay, so that is what, so that is 77 time 10 raised to power 3 newton m1 m1 omega 1. So m1 is what, that was 67500, and omega 1 was 18.42 into sine omega 1 t. So simplify this for the second mode, that q2t would be, what is 0, simple. For the third mode, q3t would be minus 77 into 67500 into that frequency is 67 60.75 into sine omega 3t. So can you simplify this? Anyone? So your,
61.929.
how much?
It was Q1 of T.
Yeah, how much q1 is?
61.929
Unit
sine.
was mm or meter?
Yeah, 0.0619.
619. 0.0619 sine omega 1t. So this is in the meter, so you can write it into the 62 sine omega 1t in mm. Okay. Similarly, the last one, it is coming out to be negative 0.01877 sine omega 3t in meter, or in mm you can write it sine omega 3t in mm. Okay.
So these are the model coordinates, Q1,
Yes.
Q2, Q3.
Yes.
Sir, actually I was having doubt, means I was not clear that what is the physical significance of these model coordinates.
We are this is the general, like for the in the first mode, if I the equivalent, like let us suppose it is happening like that, like this 3 degree of freedom system. In the first mode, what I am doing, I am finding out like how my all masses into a one particular single degree of system. If you think about it in a different way, not the technical, like I calculating m1. Okay, so the m1 contains my all three masses, m1, m2, m3. Okay, so in the first mode, what is my the equivalent generalized mass, what would be the my generalized stiffness, using that what is my displacement q1.
Okay, means considering it as a whole one
Yes,
mass.
in the one first mode, in the one mode. Okay, then finding out
Okay,
the displacement, then we are distributing it to the through the uh, my mode shape to the each degree of freedom. Like I have find out the q1, if I multiply with the mode shape phi 1, I will get distribution of the q1 in all three degree of freedom.
degrees of freedom. Okay,
Yes.
okay.
I think instead of
Interesting.
U, we are using Q, right?
No, no. Now we will find out
Uh,
the u. This is for the
yes.
model. Like in the
Uh,
first mode, how what is my model displacement for that particular? If I consider like my three as a m1 and
yes.
then a k1,
Yes.
like equivalent, we are using the equivalent property and then we are solving this.
Yes. Yes. Okay. Thank
Is it okay?
you. Yes.
So now after finding out the q1, q2, q3 in the each mode, so my response ut would be summation of q time q1 phi n. Okay, so that would be the phi 1 q1 plus phi 2 q2 plus phi 3 q3. So that would be just 0. Okay, so the phi 1 is what, zero point 0.5, 0.8661 into q1 is what, 62 sine omega 1t plus zero point 0.5 minus 0.866 1 time 19 sine omega 3t. Okay, so if you do that in each degree of freedom in each mode, that is 31, 53.7, 62 sine omega 1t plus minus 9.5, 16.5 minus 19 sine omega 3t. So these are the response corresponding to story u12, u22, u3t. Okay, so did you get the significance of this? After finding out the q1, q2, q3 in each mode, we can find out the displacement in each and every story using that phi 1 q1, phi 2 q2, phi 3 q3. Is it okay? Any doubt? No, then it is okay. So we are moving to the last question. So this kind of the same question is given to you in the, I think in the assignment, but that was for the, I think without damping. We are using here the damping, I think, and there was some little bit difference. That was some 45 kilonewton. Here we are using for 50 kilonewton. So for this, your mass matrix and the stiffness matrix is given to you, because we need to calculate these from the flexibility matrix and then we have to find out this first. So to save the time, we have done this. So in this is your u1, this is your u2 degree of freedom. So now you have the k, you have m, you have the e, I, l, ml. Can you give me the model properties, because this is the 2 by 2 matrix and that don't take much time. So can you give a try to find out the model property, because after finding out the model properties there is nothing to find out the response. So in this question what we need to do, we need to determine the amplitude and displacement, the amplitude of the displacement and acceleration by using the model damping. So we need to find out the amplitude maximum. Like we know do not need to find out in terms of the t, we need to find out the what is the maximum amplitude for the displacement and what is the maximum amplitude for the acceleration. So please give a try to find out that, like I have given the K, you have the M. Find out the model properties. So your E is given to you as a 2 into 10 raised to power 11 Newton per meter square. I is given to you 4 into 10 raised to power minus 8 centimeter per meter power 4. Ml is given to you 121,500 kilogram meter, and PT is given to you as a 450 sin 25t kilonewton. Okay, ml I is anything like, yeah, span length L is given to you 4 meter. So the mass matrix is what? Ml by 3. So if I will put the ml by 3, I am getting the mass matrix as a 40,500, 0, 0, 40, 500. And stiffness matrix, if I will solve, I am getting this as a 3240 minus 28,350 minus 28,350 3240 Newton, and that in the kilogram. Okay, so if you do that, K minus lambda m is equal to 0, then it comes out to be 3240 10 raised to power 4 minus lambda times 40,500 minus 2835 10 raised to power 4 2835 10 raised to power 4 3240 10 raised to power 4 minus 40500 lambda is equal to 0. So if you do that, like the determinant, that is 32410 raised to power 4 minus lambda into 40500 square minus 2835 into 10 raised to power 4 square is equal to 0. So if you solve this equation, characteristic equation, anyone with the lambda 1, lambda 2, can you give me directly lambda 1, lambda 2 using this? Please give me the lambda 1, lambda 2.
Actually, I got lambda 1 as a 1 and lambda 2 is 8.
How
In
much
terms
lambda 1 is how much?
1, 1. Actually, in terms of root of k by m,
Okay,
I,
then give me the omega 1, omega 2 if you are getting.
3.651 radian per second.
I think you has done a mistake. I am getting lambda 1 as a 100 and lambda 2 as a 1500. Okay, so your omega 1 coming out to be 10 radian per second on omega t is the 38.73. So your coefficient lambda when coming out to be around 1. So no, 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 that you are getting around some lambda 1 is you are getting some 9.8 something ei by ml cube. You are doing this one.
Yes, yes. No, okay, okay, okay. I got wrong. Okay, I will
So
modify.
that is your not lambda 1, that is omega 1, and omega 2 is something around 38 point something, and then ei by ml cube. So that value will become nearly 1 point something. So you will get it 10. Please find out where is your mistake, where are you doing mistake. Are you able to find out your mistake?
Yes, yes. I am doing it again.
Okay, do that.
No, I am getting omega is 3.162 radian per second. I'm getting.
In term of what?
I have substituted all the values whatever you given. Uh,
Let me check.
I am taking ml by 3 as n dash.
Yes, yes, that is okay. It is not affect your answer. Did you getting omega 1 as a 9.85 times square root of ei by ml4? I think you are doing unit mistake. How much? Uh, Tell me your this value. 162 ei by 5 l cube. How much you are taking this? Are you
Uh, yes, I'm calculating. Okay, okay. Instead of 4,000, I have taken 400. Okay.
For what?
In I, moment of inertia.
Okay, okay, okay. That's okay.
Okay.
So now you are getting same. Okay, now you got your mistake, now.
I'm getting 10 radian per second.
Yes, yes, that's the same thing you are getting. So now using omega one, omega two, you can find out your mode shape phi one, which is 1 1, and your phi two would be 1 minus 1. Okay. So now to solve the equation, we have to again mn qn double dot t cn qn t dot t plus kn q dot t time pnt. Okay. So your m1 and m2 would be phi 1 t m phi 1. So you will get it around 81,000 kilogram. So m2t phi 2t m uh, phi 2. So that would be again 81,000 kilogram. Same. Okay. So you can find also k1, k1 and k2, but in the solution we do not need that because we have the omega 1 in terms of that, and damping is the simple xi that would be utilized. And your p1 is phi 1t pt. So that would be your 1 1 time 450 sin 25t 0. That is the 450 sin 25t. p2t would be phi 2t pt. So that is again 450 sin 25t. Okay. So so the solution of mu double dot plus ku plus cu dot is equal to p naught sin omega t is what was the ut p naught by k into c sin omega t plus t cos omega t. Okay. And where c was what, 1 minus beta square over 1 minus beta square square plus 2 xi beta. This is from the chapter 2 or 3, I think. Minus 2 xi beta 1 minus beta square square plus 2 xi beta square. Okay. And beta is what, omega by omega n. Okay. So first, for finding out the first mode, for mode 1 your q1t would be p naught is how much, that is 450 into 10 raised to power 3, and k can be given, either you calculate the k1 510, or you can do it k1 as a m1 omega 1 square. Okay. So what is your omega 1, that is 10 square, and what is your m1, it is the 81,000, and that's c sine 25t plus t cos 25t. Okay. So calculate the c. So what is your beta, omega by omega 1. So omega is 25 and your omega n is the 10, so that is 2.5. Damping is 10%. How much damping we have considered? 10%. So that would be the point 1. That would be point 0.1. So can you give me the value of C? C1 and D1. Can you give me the C1 D1? You have beta, you have xi. Please calculate. Please do the calculation so that we will be able to solve this. Anyone?
C1 is minus 0.187.
Yes. C1 would be the, like, let us 1 minus 1 minus 2.5 square, 1 minus 2.5 square plus 2 into point 0.1 into 2.5 square. So that is coming out to be minus 0.188. And D1,
Minus 0.509.
so that D1 is coming out to be 0.0179. I'm getting this. Okay. So your response Q1, and that a P naught by K would become as a, if you calculate this, that would be coming out. Can you calculate P naught by K? I think I'm getting this is 0.055 meter or 55.5 mm. Is it same? Can you do once calculate this? So if I will put the final value Q1T, I will get minus 10 point.
Yes, 55.5.
Okay.
Correct.
So it is coming out to be minus 10.48 sine 25T minus 0.99. That would be 1 cos 25T. This is for the Q1. Okay. Now for the mod 2, what is my beta 2? Omega by omega n. So that is omega was what? 25 and omega n is what? 38.73. So that will be coming out to be 0.645. Damping is same, 0.1. So P naught by K, P naught by K is 450 10 raised to power 3 K2. So that is the 38.73 square into 81. Can you give me the P naught by K? How much? And then also C2, which would be 1 minus 0.645 square divided by 1 minus 0.645 square plus 2.1.645 square C2, and same D2 as a minus 2 into zero point 0.1 into 0.645 divided by 1 1 minus 0.645 square plus 2 into zero point 0.1 into 0.645 square. So can you give me the all three values? P naught by K2, C2, D2.
C2 is 1.242.
C2 is 1.242. I am getting 1.63. Let me check. Yeah.
Okay, okay, wrong. I'm on to that.
So I am getting 1.632,
Yes.
and D2 is what?
Minus 0.36.
Okay, and P naught by K2 is around, I am getting this 0.0373, so it would be 3.73 mm. Is it okay? So your Q22 would be the P naught by K2 C2 sine 25t D2 cos 25t. You will put it, you will get 6.08 sine 25t minus 1.3 cos 25t in mm. So after finding out the u q1 q2, then the displacement is the u is equal to phi 1 q1 phi 2 q2. Okay, so phi 1 is what? 1 1, and q1 is what? Minus 10.49 sine 25t minus, so 0.99 would be the 1, so that will be the minus cos 25t. Okay, plus that is 1 minus 1 multiply 6.08 sine 25 and minus 1.34 cos 25t. Okay, so now your response for the each story, u1 first story and second story, that is coming out to be minus 0.441. If you add it, sine 25t minus 2.34 cos omega t, and that is 60.57 sine 25t plus 0.34 cos omega t. Is there any doubt up to this? So now to find out the amplitude, what we do for the u1, we can directly find out 4.411 square plus 2.34 square, simple. And for the u2, that would be the 16.57 plus 0.34, this one. Okay, any doubt in this? So how much we are getting, that you can do 4.41 square plus 0.41 square plus 2.34 square. If you take this root, so that is coming around to be 5 mm, and for this, that is coming around 16.57 mm. Okay, any doubt into this? So your Story shear maximum amplitude for displacement. Now, can you find out maximum maximum amplitude for acceleration? So that would be the u double dot one would be the omega square u1, and u2 double dot would be the omega square u2. So omega is what? 25 into 5. So that is the 25 into 16.57. So that will be coming out to be mm per second square, or if you want to calculate in the meter, so that would coming out to be 3.125 meter per second square. And if you calculate this, so that would be coming out to be, that would be in the meter mm per second square, and in the meter per second that would be 10.35 meter per second square. So these are your maximum amplitude at the each story. Is there any doubt? Anyone? Any question? All five questions we have solved. So that was our last problem.
That U1 double dot came from equation derived for two times, right? Differentiation for two times. That U1.
What?
U1 double dot is
Yes, acceleration is what? That is the omega square times the displacement.
no, no, we have we got expression from in terms of sine and cos, right?
Yes, yes. So that is the function of the time variation. But
Yeah.
we are interested in finding out the peak response.
Okay. Okay.
So for the
Then
peak response, we are doing the same. If you remember, like if we have some coefficient a sine omega t, b cos omega t. So what would be that response? That would be the
okay.
square root of a square plus b square. And for the acceleration, you would do the same. Only 25 would come out to be, so that 25 square is multiplied.
Okay. Okay. In a assignment, tenth assignment, the first question we have other than relay damping, that is Cauchy damping something. CAUGHEY damping.
That picture, what was that?
In assignment 10, first question.
Yes, let me look into that. What was that? So in the assignment, that was the question regarding the correct and incorrect.
Yes, yes. You know this relay damping.
Yes.
What about this another damping is there, no?
What's it?
Cauchy.
So regarding this, that you can look into the, like in the core during that course is covered or not.
No, no. In the course, sir has not covered.
So if you can look into the book, like from that you can find out. I think that is easy. A simple line like coach damping, consider damping ratio in more than two mode. Is it correct or incorrect? So you can look into that. Coach damping ratio in each mode is given. So these are the formulations.
Okay. Sorry, where we can find this? I am
Y-
not.
you can go through the Chopra book,
Chopra. Okay, okay. Chopra.
Chopra book or any other book like Clough and Pinjan. Any there are a lot of books. So those formulations will be remain same irrespective of the books.
Okay, okay.
Sir, I have one doubt.
Yes,
Means in our college, actually, there is one lab of structural dynamics,
yes,
and there are different setups. Like there is a three-story model is there,
yes.
and for that they are giving base motion, simple harmonic motion to the base, and
Okay,
we have to find the natural or mode shapes
okay.
for that particular story. Means for that, sir, which part of this Chopra shall I go through, or have we covered such type of problems?
Like there is a system in your lab. We are you are giving the forcing frequency.
Yes, means there is a machine on which we can set the RPM frequency 100, 200,
Okay,
and because of that, the base of the structure moves, and because of that, there above there are three stories. They also
okay.
get vibrate, and there is
So
accelerometer also. That
okay, so you are getting the response from them. So are
yes,
you? So you are making the frequency like the what we call it frequency response curve. So for the each story if you are getting that, so when you apply the
okay,
frequency at the base at the different like you are giving the like excitation at the different frequencies. Okay, you are giving
yes,
some
yes, yes,
sinusoidal set
simple harmonic, huh?
simple harmonic
Yes,
with
yes,
different that. So you can find the
external
response
frequency.
like
Huh?
at which frequency is your peak is occurring resonating condition is occurring, that will be your model frequencies. From that you can find out if you have the response of the acceleration. So for the like when you give the like let us suppose you are giving the forcing frequency like the your forcing harmonic motion from 1 to 50 hertz. Okay, so it
Okay,
so from that you can find out like where is the resonating condition is occurring from 1 to 50. At that places where the
okay,
resonating condition is occurring, that will give you the your model, like that is your model frequencies, that will give you omega 1 omega 2 omega 3. So in the
okay,
book
okay,
you
okay.
can go through the half power bandwidth method in the Chopra book, or you can follow the
Yes,
V3 or
yes.
V2 half power bandwidth. From that we find out the damping. Such questions are such setups are to find out the experiment for the finding out the damping of the system. So you are
Okay,
applying
okay,
the harmonic excitation, you are finding out the response, and then using that you are making the frequency response curve. So from that curve you can find out the like the what is your damping of the system. Is that kind of
okay.
experiment
Means
is there?
that yes, yes. Means that was for single degree, na half power bandwidth, or it can be used for multi degree also.
For multi degree also can use for the different story what you are getting the response, because that is the omega by omega and ratio and then the response at that particular story. So using that you
Okay,
can
okay,
try with that. So chapter 2 or 3, and for the multi degree of freedom also the like you can go further chapters, like in the chapter 12.
means have we covered yet such types of questions in our means
In
week
our
or
like
not?
the single degree of freedom we have covered that kind of thing.
Okay, okay,
And the
okay.
half
Not for
hour,
multi degree.
yes, and the half hour bandwidth and that all are considered include in the during the lecture sir has included those things.
Yes, 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 yes. I have listened all the lectures, but it was multi degree, and uh, we have to find out the mode shapes.
So for the multi
That
degree
was
you
the
can see the response, you have the response, and at the response which frequency you are getting the resonating condition resonance the higher peak, that would be your model frequencies.
okay, sir. Okay, okay. I will see.
Yes. Even though
Okay.
without like for the 3 degree, that is the forcing excitation. With the free vibration also you can find out the mode shape in your lab setup. Like you give some initial displacement and then leave it to
Yes.
then leave to vibrate this, and then the measure the response at what frequency it is vibrating. You can find out that time period. That is also one thing.
Okay, 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 sir. Okay. Thank you, sir.
Okay. Anyone? Any other doubts? Or should we conclude the lecture?
Yes, sir.
Okay, if you don't have any doubts, you may leave the session.
Thank you, sir.
Okay, thank you everyone
Thanks, sir.
for
Thanks a lot.
joining.